Howdy. I'm a normal or Gaussian distribution. Not every symmetrical bell-shaped curve is normal. Just ask my friends Cauchy and T. What makes me normal? It's not that I'm typical or common. I actually have a very specific definition. The general shape of my curve is fixed, but the center and spread is modulated by my two parameters. Mu, which determines my mean or center, and sigma, which determines my spread. The reason I am so useful and come up so often is because of what's known as the central limit theorem. It basically says that no matter what distribution your data comes from, sample means will follow my shape. It's not that your data will be normally distributed. It's that if you and a whole bunch of other people all took your own random samples and then made a histogram of everyone's sample means, that histogram of means would look like me. I'm the distribution you've relied on when you quickly add and subtract 3 standard deviations and declare that 99% of the range is covered. Or guesstimate that plus minus 2 standard deviations covers 95%. Less used is that plus minus 1 standard deviation from my center covers 68% of my area. And fun bonus, the plus minus 1 standard deviation mark aligns with the inflection points on my curve. Those sigma rules aren't universal. They don't work with my friends T or Cauchy. They don't work with most distributions named or otherwise. Here's some examples of some distributions with plus minus 2 sigma ranges and the corresponding percent coverage. Some are close to 95%, but not all. What is a standard normal? Pretty simple, really. It just means mu, the mean, is equal to 0. And sigma, the standard deviation, is equal to 1. That's it. To transform any normal distribution into a standard normal, you can calculate what's called the z-score. This simply recenters to 0 and rescales to a sigma of 1. And there you have it. The normal distribution in a nutshell. I am symmetrical and bell-shaped with a very specific formula describing my curve. I am defined by 2 parameters, mu and sigma. The central limit theorem, a theorem that describes the shape of sample means, is what makes me so useful. The 95% within 2 sigma rule of thumb is based on me and is not universally true. A standard normal has a mean of 0 and a standard deviation of 1. And a z-score is a way to standardize that calculates how many sigma a point is from the mean.